right, so on, what was it, Monday, we reviewed kind of finding slope, graphing lines in standard form and in slope-intercept form. What we are going to start off reviewing today is using point-slope form to write the equation of a line. So what I want to start off reminding you is that regardless, no matter what information that you are given, we will always ask for your answer to end up in slope-intercept form. So again, just quick review. Remember, that's our y equals mx plus b, where m is our slope and b is our y-intercept. Okay. What you'll do most of the time when we're working with this, though, is you're going to start by using what we call point-slope form. Okay. So this probably will look familiar to you. Y minus y1 equals m times the quantity x minus x1. The reason why this is called point-slope form is because if you have a point on the line and the slope of the line, you're going to plug in your information and then it will end up giving you the equation of your line. So quickly again, that variable m represents your slope. And then the variables x1 and y1 is a point on your line. So we have a few different examples given different pieces of information. And again, we are going to end up for all four of these in slope-intercept form. For the first example, we are just kind of straight given the slope and the y-intercept. There's not really a whole lot of work at all that we need to do here. It's just kind of a matter of recognizing what we're given and plugging them in the right place. So if our slope is 2, that's our value of m. If our y-intercept is -5, that's our value of b. So we can just go ahead and plug those values for m and b right into slope-intercept form. When we go to the next example, so again, different pieces of information, we're given two different points that our line passes through. The first thing that we need to find, what do you guys think? Remember from algebra? If I want to use point-slope form, I have a couple points, but what do I not have? Slope. So we're going to start off by finding the slope that goes through these 2 points, which something that we talked about a little bit yesterday or Monday. So we're going to take the difference in the y values, 8 minus 2, over the difference in the x value, 6 minus 4, and simplify to find our slope. I tend to kind of get going and I tend to speed up if I'm ever like talking 100 miles an hour, just be like, whoa, back your truck up, Mrs. G, slow it down. You won't offend me. I get all excited about math and I get going and sometimes I just I'm a big nerd. All right, once we have that slope, then we can take that slope and choose either one of those points to use our point-slope form. It is completely your decision which of these 2 points you choose. It makes absolutely no difference. I usually just pick the first one just because. So if I choose that first point to use, these again are the values of x1 and y1. So we'll plug those values of 4 and 2 in, as well as our value of 3 for slope. So this will give me y minus 2 equals 3 times the quantity x minus 4. From there, anytime we have a number or negative or anything in front of a parenthesis, that tells us to multiply. So we are going to distribute that 3, which gives me 3x minus 12. Just bring down that y minus 2. And then we are almost there. Remember, we want this in slope-intercept form, so we want y by itself. So the very last little thing that we need to do to make that happen is just add that 2 to the other side to get y by itself. So adding the 2 gives me y equals 3x minus 10. What questions do we have? Okay. Couple other things using point slope form. Let's talk briefly about parallel and perpendicular lines, and specifically what we know about the slopes of parallel and perpendicular lines. So if you think back to kind of Algebra 1 and geometry a little bit, we know that parallel lines are lines that are never going to cross. And what about them makes them not ever cross? Exactly. They're never going to cross because parallel lines have the same slope. So if you're asked, like in this example, to write an equation that is parallel to a given line and goes through a certain point, that point is going to be the values of x1 and y1. And then what information do we need to pull from that given line if we want to be parallel to it? The slope, exactly. Tell me your name again. Katie. Okay. Katie? Kaylee. Gosh, I'm sorry. Kaylee. That will never forget. Okay, so Kaylee, what is the slope of that line? Okay, so we're going to take a slope of -3, values of 0, -4 for x1, y1, then we can go right to our point slope form again. So we'll plug in, okay, we need to be a little bit careful here. This is y minus, and then we have a -4. So just really kind of watch those negatives. It's the biggest mistake that you guys will make. -3 in for our slope, and then 0 for x1. We can then again distribute that -3. So since we have a 0 here, we're just going to end up with a -3x on the right-hand side. And then what I'm going to do is I'm going to go ahead and make that minus a negative a plus. So I'm going to bring down y plus 4. And then when we move that to the other side, it will be by subtracting. So let's go ahead, just to kind of give you, I know a lot of you have never used a graphing calculator before, and again, I know we don't all have them right now, so just kind of trade off. But I just wanted to show you how to just graph a basic linear equation. So grab a calculator, and again, if some of these have dead batteries, I'm sorry, I'll have to work on that. I'm going to do it all up here, so if you're not working with one right now, just kind of follow along up here. These are all things that we'll go through again. In order to graph just kind of a basic linear equation like we have here, the very upper left-hand button says y equals. So if you click that, this is what you should see. If there's junk left over in there, you can just delete all of that. So in your Y1, let's type in negative, and here's the deal with the graphing calculator. To type in a negative, you have to use this button. It's not going to read it correctly if you use the subtraction sign, okay? So a negative and then 3. And then to type in your variable x, there's a button right here underneath where it says mode. So click that and it should give you an x. And then let's go ahead and do the negative 3x plus 7. So then just basic plus and then the 7. Is that one dead? Is that one dead? Okay. Now, let's double check that the equation we ended up with is actually parallel to this one. So if you use your cursor button and scroll down to Y2, we can go ahead and also input the negative, what was it? Negative 3x minus 4. So same way, negative 3x minus 4. And then to graph, there's a button, very top right-hand button says graph. Click that. Now, you might be seeing something different than mine because my window, I was playing around with some pre-cal stuff earlier. My window is all messed up. So if you have kind of a zoomed in window or zoomed out, if you go to your zoom button, which is top in the middle, number 6 will take you back to a basic standard negative 10 to 10 window. Okay. So we can see on our calculator that those lines are in fact parallel, which is what we wanted. Okay. Now, I understand that you guys, again, have not really used these. You may have just gone out, the last couple of days and bought it and haven't even opened it. If you did not catch everything I said, it's okay. All right, we are going to keep working and keep working so that we learn some things that will be helpful for you. Okay. You can always see me if you're working on something in AL and your calculator's just giving you fits. Come see me because I'm really good on troubleshooting the TIs. I'm magic with the TI. Casio, again, I know a little bit, but you guys are just really going to have to kind of play around with learning how to work those. Okay. All right. Just wanted to kind of show you some basic how to graph a line on your calculator. Let's go ahead and go back to example number 4. All right, so in this example, we are wanting a line perpendicular to a given line passing through a point. So again, that point we are given is our x1, y1. But this time we want it perpendicular to the given line. Now, this one is made even more difficult because the equation that we're given is in standard form. So the first thing that we need to do here before we can do anything else is we need to put this in slope-intercept form. So let's go ahead and start off by subtracting 2x. And then we'll divide everything by 3. So writing that given line just in slope-intercept form. Oh, another thing I should mention. You have probably noticed I don't write plus whatever on both sides. I don't write divide by whatever. You guys might be used to seeing that. So if you kind of miss where I went from one line to the next, just say, hey, Mrs. G, how'd you get that or this? Because every once in a while I make a mistake. So you might be wondering where I got something because I screwed up. But if you, were writing something down and missed, what happened, just let me know and I'll go back over something. Okay. But we're getting to the point where I don't really want you to, if you still really, really want to write all that work out, that's fine, but I don't require it. It kind of gets in the way, if you know what I mean, of what we're really getting to. So If you've had to do all that work in the past, you don't anymore. Now, that's not to say I don't require any work, but I don't require divide by 3, you know, those sort of things. Okay? So, with that being said, what do we know about perpendicular lines and their slopes? Do you remember this one? This is the, no, parallel's the same. Okay, perpendicular lines make 90-degree angles, but what's special about their slope? They're opposite reciprocals. Yep. Opposite reciprocals. So that means you would flip your fraction, that's the reciprocal part, and then change the plus or minus sign. That's the opposite part. So if I'm wanting a line perpendicular to this one, what is our slope going to be? Basically, what is the opposite reciprocal of negative 2/3? Flip it, change the sign. Say what? 3/2. So the negative becomes positive and we flip that fraction. So the slope that we are going to use for our line is 3/2. From there, we can take the slope and the point, go back to our point slope form. So plugging in a -1, again, be careful with your negatives there. Plugging in 3/2 for m and 6 for x1. Again, go ahead and distribute that 3/2. Actually, I'm going to make that minus the -1 a plus as well. So y plus 1. And then distributing 3/2 will be 3/2 x minus 9. And then the last thing that we need to do is just subtract that 1 over and we will have the equation that we want. Questions? That's probably about a couple of weeks worth of Algebra 1 class, all in about 10 minutes. All right, let's look at the next example. So we kind of did our Algebra 1 review to kind of get us back into it. So now we're going to kind of step it up and look at how we can apply this content really to some more real-world examples, if you will. All right, so it says a prom venue charges a rental fee plus a fee per student for the students at this high school to attend. If 100 students cost $1,500 and 150 students cost $2,100, write an equation in slope-intercept form that models the total cost C in terms of the number of students P, and then interpret the slope. So we'll worry about that later. First of all, we need to pull out the information that we are going to use in order to write our equation. So you can kind of see the 4 different numbers that you have here. So let's talk about this for a minute. We're looking to write an equation for total cost. What in this problem determines what your total cost is going to be? The number of people, exactly. So that number of people is what we call the input, basically the x value. And then that total cost is what we call the output. Okay? Because the number of people determines the charge, we will set up our ordered pairs in that order. The number of people determines that charge. So for example, when we have 100 people, our cost was $1,500. So we're putting that information in an ordered pair. 100 people determines a charge of $1,500. What would our other ordered pair be that we can pull out of here then? I hate not knowing your names. Cameron, right?
Yeah.
Okay.
150 and then 2,100.
Good. Okay, because when we have 150 people, our charge is $2,100. So kind of the algebra 2 version is we have to pull out those ordered pairs. Now from here, it's what we did above, just using point slope form with those two ordered pairs. Oh, we need to start off by finding the slope. I'm getting a little ahead of myself. So let's find our slope first. So I'm going to, again, take the difference in my y values over the difference in my x values. All right, on top I end up with 600. On the bottom I end up with 50. So our slope ends up being 12. Now that we know the slope, now we can go to our point slope form. Again, you can choose either of those ordered pairs that we pulled out of the information at the beginning. Again, I always just pick the first one just because. So I'll plug in 1,500 for y1. Our slope is 12, and then 100 for x1. All right, I'm gonna kind of let you guys talk a little bit. I've been talking way more than I typically like to. So here's what I'm gonna have you guys do. With your table, I want you to finish that up, which is not a whole lot to do. But here's the big thing that you need to really discuss in your group. This is not something that you've really been asked to do before, is what we say, interpret the slope. What that means is describe in words. So you're going to be writing like a sentence or two here. Describe in words what the slope, so you're thinking about the number 12 specifically, what the slope means in the problem. Okay. So I'm going to give you guys a few minutes, like I said, finish up writing the equation, and then talk through with the people at your table, what do you think that slope of 12 means in terms of that problem? Okay, go.